Hello, I'm Maruk Said, your microbiology guide. Let's explore in-depth micro techniques and uncover groundbreaking insight together on this educational journey into the fascinating realms of microbes.
Selenite F Broth explained composition, uses, and Shigella detection. Table of Contents. Introduction to Selenite F Broth. Composition. Principle. Preparation. Result interpretation. Uses. Limitations. Introduction to Selenite F Broth. Selenite broth was originally formulated by Leifson, who identified that the compound selenite had inhibitory effects on coliform bacteria and certain other microbial species commonly found in fecal samples, including fecal streptococci. This selective inhibitory action made selenite broth particularly useful in enhancing the recovery of Salmonella species from mixed microbial populations in fecal specimens. A specialized formulation of this medium, known as Selenite F Broth, is used specifically as an enrichment medium, which supports the growth of Salmonella while suppressing the growth of competing bacteria. Selenite F broth is buffered with lactose peptone broth, which helps to stabilize the pH of the medium during bacterial growth and metabolic activity. The selective nature of this medium is due to the addition of sodium biselenite, which acts as the primary selective agent by inhibiting the growth of non-Salmonella organisms. Because of its selective and enrichment properties, Selenite F broth is extensively used for the isolation of Salmonella species from a variety of sources that may contain a mixture of microbial flora. It is widely applied in microbiological analysis and public health laboratories for examining feces, urine, water, food products, and other materials that are of sanitary importance and may be potential carriers of pathogenic Salmonella. The medium plays a crucial role in both clinical diagnostics and environmental or food safety testing by increasing the likelihood of detecting Salmonella even when present in low numbers. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Composition of Selenite F broth. The composition of Selenite F broth is specifically designed to support the enrichment of Salmonella species while inhibiting the growth of competing microorganisms, particularly coliforms and fecal streptococci. It contains casein enzymic hydrolysate, 5.0 grams per liter, which provides a rich source of amino acids and peptides essential for the growth of Salmonella and other fastidious organisms. Lactose, 4.0 grams per liter, is included as a fermentable carbohydrate, supplying an energy source that supports selective growth within the medium. Sodium phosphate, 10.0 grams per liter, acts as a buffering agent, helping to maintain the stability of the pH during bacterial metabolic activities and fermentation processes. Sodium hydrogen selenite, 4.0 grams per liter, serves as the key selective agent, inhibiting the growth of non-target bacteria, such as coliforms, thus favoring the selective enrichment of Salmonella spp. The pH of the medium is adjusted to 7.1 plus or minus 0.2 at 25 degrees Celsius, which provides an optimal environment for the selective growth and enrichment of Salmonella, while maintaining a stable biochemical environment. Principle of Selenite F broth. The principle of Selenite F broth is based on its selective enrichment capacity that promotes the growth of Salmonella species while suppressing the growth of other competing organisms in clinical and environmental samples, Casein enzymic hydrolysate functions as a vital nutrient source, supplying nitrogenous substances, carbon compounds, and essential vitamins that support the metabolic activities and growth of Salmonella. Lactose acts as a fermentable carbohydrate that helps maintain the pH balance of the medium by producing acidic byproducts during fermentation, which neutralize the alkaline conditions produced by bacterial activity. During bacterial growth, selenite, in the form of sodium hydrogen selenite, undergoes reduction, which is often accompanied by the production of alkaline substances. This increase in alkalinity can reduce the toxicity of selenite, which may lead to the overgrowth of non-target bacteria if the medium is incubated for too long. However, the acid produced by lactose fermenting bacteria counters this effect by maintaining a neutral pH, thereby preserving the selective pressure of the medium in favor of Salmonella. Sodium phosphate acts as a buffering agent, playing a dual role. It maintains a stable pH and simultaneously reduces the toxic effects of sodium biselenite on beneficial organisms like Salmonella. Sodium hydrogen selenite, sodium biselenite, is the core selective ingredient of the medium. It is highly toxic and corrosive and is also known to cause teratogenic effects, emphasizing the need for careful handling. It inhibits a broad range of both gram-positive and gram-negative organisms, including Enterococci and coliform bacteria, which commonly outcompete Salmonella in fecal and food samples. Incubation time is critical. The broth should not be incubated for more than 24 hours, as the inhibitory action of selenite diminishes significantly after 6 to 12 hours, potentially allowing overgrowth of unwanted microbes. Preparation of Selenite F Broth. To prepare Selenite F Broth, begin by adding 4.0 grams of sodium selenite powder to an appropriate volume of distilled or deionized water. This component serves as the selective agent essential for inhibiting unwanted bacterial growth. Next, add the remaining 19.0 grams of dehydrated medium, which includes casein enzymic hydrolysate, lactose, and sodium phosphate, to the same solution. Adjust the final volume to 1.0 liter with distilled or deionized water, ensuring all components are completely dissolved. Gently heat the solution while stirring and bring it to a gentle boil to fully dissolve the medium constituents. Avoid excessive boiling to prevent degradation of sensitive components. Once dissolved, dispense the medium into sterile test tubes, making sure each tube has a depth of at least 5 centimeters to provide adequate volume for inoculation and incubation. Do not autoclave this medium, as autoclaving can decompose sodium selenite, thereby reducing the medium's selectivity and effectiveness. Instead, sterilize the tubes by placing them in a boiling water bath or subjecting them to free-flowing steam for 10 minutes to ensure sterility without compromising the selective agent. After sterilization, allow the medium to cool to room temperature before using it for inoculation. Proper cooling ensures that temperature-sensitive microorganisms are not harmed during sample addition. Result interpretation on Selenite F Broth. Result interpretation of Selenite F Broth is based on visual changes observed in the broth after incubation and confirmation through subculturing onto selective agar. Following incubation at 35 to 37 degrees Celsius for 18 to 24 hours, the growth of organisms in the broth is indicated by the appearance of turbidity, cloudiness, in the medium. Turbidity signals successful bacterial proliferation. To confirm and differentiate the type of organism enriched in the Selenite F broth, a subculture is performed on McConkey agar. The results on McConkey agar help distinguish Salmonella and Shigella species from other enteric bacteria. A positive result is observed when the subcultured colonies appear colorless, with good growth on McConkey agar, indicating the presence of non-lactose fermenting organisms such as Salmonella typhimurium, Shigella sonnae, Salmonella enteritidis, and other similar pathogens. These organisms do not ferment lactose, hence they do not produce acid that would turn the colonies pink, and their ability to grow confirms successful enrichment in the Selenite F broth. A negative result is identified by pink colonies with bile precipitate, or by inhibited or no growth on McConkey agar, suggesting the presence of lactose fermenters or organisms sensitive to sodium selenite, such as Escherichia coli, Enterococcus fiacalis. These organisms either ferment lactose, turning colonies pink, or fail to grow after enrichment due to the inhibitory effect of selenite, confirming that Selenite F broth successfully suppressed non-target bacteria. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Uses of Selenite F broth. Selenite F broth is primarily employed as a selective enrichment medium designed for the cultivation of Salmonella species from clinical specimens, food samples, water, and other materials of sanitary concern. Its selective components suppress the growth of competing microorganisms, thereby allowing the target Salmonella organisms to proliferate for easier detection and isolation. It is also effective as an enrichment medium for the isolation of certain Shigella species, although Shigella is more fastidious and may not grow as robustly as Salmonella. Nonetheless, the broth can support the selective recovery of Shigella from contaminated specimens when present in low numbers. In addition to its use with enteric pathogens, Selenite F broth is recommended for the short-term transport of Vibrio cholerae strains. These organisms can survive for 2 to 5 days in sodium selenite broth, making it a useful option for maintaining the viability of V. cholerae during transit to the laboratory for further analysis or identification. Limitations of Selenite F broth. Sodium hydrogen selenite, sodium biselenite. The key selective agent in Selenite F broth is extremely toxic and corrosive, and is also known to cause teratogenic effects. It must be handled with extreme caution, and in case of skin contact, the area should be immediately rinsed thoroughly with plenty of water to minimize harm. Selenite F broth should not be used as the only medium for isolating pathogens. It is designed for enrichment purposes only and must be used in combination with selective and non-selective solid media, e.g., McConkey agar, XLD agar, to improve the chances of isolating target organisms, especially when they are present in low concentrations in the specimen. Some bacterial strains may exhibit poor growth or may not grow at all in this medium due to differences in nutritional requirements or sensitivity to the selective agent, which may limit the detection of certain pathogens in specific samples. Thank you so much for watching. Don't forget to subscribe to my channel, press the bell icon button. Thank you!